For today's webinar, we are going to cover the automotive industry again. And today's is an automotive, drum roll, automotive exhaust. So with this one, we have a really neat scan, as you can see over here on the left-hand side. We have a really neat model of an exhaust, and you can see right next to it we have the CAD model, which is a screenshot of what we're going to cover today. And the reason why this one is good is it's a great example that we see quite often. Lots of aftermarket exhaust products are made out in the markets, and 3D scanning is a great way to capture the existing assembly condition to model from and recreate that and make modifications to it. So this is just a huge industry here where you can scan the whole region and model a new design inside of it. So today's, you'll notice that the scan data isn't your typical scan data, and I'll get into it when we switch over to DesignX. But there are instances where you can reverse engineer 3D scan data that comes from a 3D scanner like you see in the image on screen. But there are also times where you can bring in polygon data from other places that isn't even a scanner. And I'll show you when we load up the model what I mean and how we can deal with that. But with that, we'll go ahead and jump over to our next slide, and then we'll dive into DesignX. As usual, before we get started with our DesignX portion of our webinar, I always like to bring up this slide. I know for some people that watch weekly, this slide can get a little redundant, but we just wanted to make sure that everyone that jumps on the webinar understands the workflow and where DesignX fits in here. So as you can see here on the left-hand side, we have different types of 3D scanners, and DesignX has the ability to connect to those scanners with plugins and import tools. And we have done it for over 30 years, so we have every kind of importer, file type, plugin imaginable to connect to these different types of 3D scanners. And then DesignX is really a CAD platform that utilizes our own scan kernel that we have built from the ground up internally that allows us to handle all that scan data as native entities, bring that in, process it in a way that we can extract model information from it, whether it's CAD model information. Sometimes people want to go straight over to additive, as you can see on the right-hand side. But many times people want to extract CAD model information, both design intent or as built, and send that over to CAD. So by far the top section there is the number one output, where we have a live transfer tool that will allow you to transfer over the CAD information as native entities over to these different CAD platforms. The second one down is we can then save out models like step, IGESet, neutral, all these different native interchange formats to send over straight to CNC packages for cutting stuff directly, or additive. Some additive packages will take CAD models or meshes, and we can save out to those as well. But that's what DesignX's overall workflow is to handle that heavy lifting of grabbing scan data, bringing it in, processing it, extracting just the CAD information or 3D model information that you need, and sending it out to the proper output. Now, there's a whole other host of things that you could probably do. These are just the highlights of the different applications that we send out to on a routine basis. So with that, we'll go ahead and jump over to DesignX for our presentation. So here is the data set from today. I hesitate because it's not scan data. This is polygonal data. It's a polygonal mesh, as you can see over here. And I can expand it over here. If I zoom in, you'll see that it looks a little different. It's like very pixelated, but very geometric. And if I zoom in and show you here, you'll see, there we go. Now, what happens in certain industries, I've witnessed this in a few, aircraft and automotive, where some companies actually are able to get data from the manufacturer, but it's not CAD data. Some of these manufacturers, I guess, based on different kinds of right to fix or type laws, that manufacturers have to turn over some information about the objects, but it doesn't have to be CAD, right? So I've seen this before in the automotive and aerospace where companies are given these polygon meshes, but you can't manufacture off of this. I mean, this would be brutal to try to work with, but you can take this scan data and reverse engineer it to create your CAD models from there. And that's an example that we see here where you can bring in. You'll notice that they're very lightweight. Like this is 64,000 triangles. That's like nothing there. And you see here we broke this one piece up. I'll turn off that. This is only okay. That one's like a million. Uh, so they might have raised the resolution on this one by subdividing it, which we'll talk about here in a second. But yeah, this is non-scan data. So you can reverse engineer stuff, polygonal meshes. I've also witnessed people download polygon meshes to reverse engineer into CAD from all of the different websites that produce print models for your 3D printer. And sometimes you may not want to print it, but you may want to take it over to a CNC package. And so you can open up the polygon meshes from those locations, reverse engineer them, and go from there. So, again, actually, one other industry I'm thinking of now, sometimes in the consumer products market, companies, media companies that make animated movies, those animated models sometimes will get turned over to toy companies as polygon meshes, low res like this, where you can reverse engineer them to then create manufacturable models out of as well. So that's another one too. Um, so we'll just dive right in here and roll back. So boom, roll back. It's a really lightweight model, so it should roll back pretty quick. So right now you'll see that again, this is the original piece there. We'll turn that on and off here. But what they did is, let's just go ahead and show the edges. You'll see that the edges are a little bit higher. Originally, this area was probably all one triangle. So one thing that we do with these types of meshes sometimes is come into polygons, and these meshes are too low for us. So we'll come in and we'll say, I want to subdivide by 4x or 3x or by an edge length. So if you zoom in here, 4x will actually take this one triangle and connect the midpoints together and put a triangle in the middle of that one, thus making it four triangles. 3x is what they take the midpoints and connect the midpoints together in the middle to make three triangles out of it. And then edge length, you can do something along this line and fill these and then tell it an edge length multiplier with a minimum and a maximum edge length, and then a defeaturing level as well. I don't use that one that much. Let's just do this one real quick and click on the mesh. Actually, let's do that. Yeah, let's just click on this one triangle and tell it to 4x it. Just that one. So let's just do that one more time. So come in and subdivide. Just window in a few of these here. And subdivide those triangles. And now you see that we subdivided, we raised the resolution of them. So you see, you could thus take the entire thing here, just select the whole thing. That's usually what I'm doing. I'm usually not like selecting one triangle and doing that, and then you just hit OK, and boom, it makes up all the intermediate triangles, raises the resolution, because our software wants more triangles than this. When it does its averaging by best fitting a plane or a cylinder or whatever, sometimes it's too low to actually work with, and this will make it easier to deal with and give us more statistical data to work with to average out and create a more accurate model. So, yeah, subdivide is a really neat tool. Sometimes you could subdivide it up and then reduce it back down if you want to. If you want to decimate it back down to a certain level, to a certain exact triangle count. That's basically the reason why you'd want to do that. Because you look at, I raised this now to 3 million triangles. So you could then come back and say, I want to reduce it back down to 1 or whatever, like this. We'll go ahead and do it. Why not? There we go. Hit OK. And boom, we are reducing it down. Drop it down. Now, when you do that, it's going to restructure the triangles there and try to keep them in certain areas. So whether or not you want to do that is up to you, but it should be fine. All right. So let's go ahead and roll forward. So it looks like here we are going to worry about the back strap here and go ahead and extract that with just a surface extrude. So you could use again, you could come over and use our favorite extrusion wizard, or you can slice down that and extrude it as a surface and go from there. And now we're going to go ahead and extrude on the side there as well. If I just turn my surfaces off for a second, you see here that they just went and grabbed along that edge there. And we'll keep on rolling. Looking good so far. And these should be a lot more fun to reverse engineer because there, in theory, shouldn't be tons of error in it because it's a converted, exported CAD model is what we're reversing right here. So I would imagine that there's a lot less decision making as far as like extracting and making decisions about error, trying to average out error as you're modeling here. And I'll just turn off the polygon mesh real quick just so you can see what we're extracting. And then now we'll just keep on keeping on. So this is another one of these fit. We're going to fit here, fit there, trim these tools together. And just turn that off and turn that on. You see we had this piece there. Just break it down into smaller pieces, right? And just nibble away at it by fitting the individual sections and trim them all together and fillet them where possible. As you can see here. And then we'll roll forward there. Now we're fitting these guys on the side. And I will, after this trim, I'll go ahead and turn some stuff off so you can see. So after that trim, turn the polygon off. So we just worried about that one, treated this as one part and model all of it, right? And then we're going to trim it in with the main piece. Fillet the pieces together first, like that, and then trim it in with the main piece. So we're fitting there on each side. Just moving forward there. And you'll see that there was this extra notch. So we're going to worry about that now. Trim all the way up and down. Fillet trim again. And now we'll just jump forward a few more trimmy trims. All right, now's a good spot to just kind of take a look at where we're at. This is the stage that we're at, where we've trimmed. I separated this all as one area. Modeled this, this is one piece, that is another piece, and then now we're trimming it all. Now they're going to apply some fillets here to all of that. Then let's jump forward. I don't want to bore you guys here with some of this because this is like a lot of repetition, but it really helps to see the approach. Like what I'm trying to teach here is let's just look at what they're doing and where and when. So now we're going to start wrapping. Basically, we wrapped around this side and we laid out everything and trimmed it together. We didn't do the edges yet. The edges are going to be another step probably at the end. Now we're going to wrap around here and fit all these facets all the way around. And trim them together first. Now jump forward a few more steps and trim. So fit all of those. Like so. And then apply some fillets and trims. Fillets and trims and fillets. And then we'll turn this back on here in a second. All right, so let's just take a second. Turn that, because this is now a separate tool. You got like the main piece there, and then now we trim together the second piece. We'll see where we go. We're on this wild ride together. All right, so now jump forward a few more where we fillet that, and then looks like we're going to finally introduce a solid. And that solid, let's just hide that guy. We'll hide the solid too. So we're going to model that as a solid. And gotcha. We modeled it as a solid, deleted the faces, made it a surface. So you can do that too. That's another thing. Sometimes it's easier to do something like that. I'm not sure exactly in this instance why they did that, because they could have just extruded it as a surface, but they modeled it as a solid, deleted a face to make it a surface. So now, trimming that together. Maybe they wanted this to exist, I guess, already without having to model in a couple different steps. And here, let me do this. Turn that off. Yeah, I see why. They modeled it as a solid because they wanted to not have to model extra surfaces because this is eventually going to get trimmed away. All right, so now we did a revolve surface there, and I'll roll up there. This was an extruded surface all along that side right there, this guy, and then trimmed them all together like that. Then we are going to fillet. And let's just pause a second, turn off the surfaces, turn off the poly. So for the poly, they need to finish this right here, right there. Everything else is looking great. And then they're gonna have to fit these flats. Looks like these all might be part of one direction. So you might be able to fit these all as one extruded surface. We'll see where they go with that. Now, step forward. So still down here, they're working down here. Turn that off. So now we are trimmed together and we went all the way down this side with all of this. There's a separate tool. Then we add the rounds. And here. Cut all those together. Here, let's turn on the mesh there. And of course, there, we're going to do that. Then we're going to do that. All right, so let's just double check. There's our other surface. That looks so good. Look at that. And so look at this. This is just trim city. A full city of trims here. Now I'm going to jump forward a little bit more because you're going to see there's a whole other section of parts here that we're going to just go quickly over. I don't want to bore everybody, but all right. So now the entire interior, for the most part, is completed. So we're going to go around and trim the exterior. So if I hide the mesh, you see here that we got this going around to trim everything. So we will go forward. So now we trimmed. So instead of trimming it in pieces, it looks like they're building one big old trim tool. So let's see where we go from here. So jump forward a few more steps and building our mega trim tool from all these different angles. Oh yeah, we gotta turn it back on. Yep, it looks like all of that's trimmed together so far. And we're just gonna keep on keeping on and finish all of this. And it looks like we're gonna extend. You can see it takes just a second to regen because to roll forward because it's just a lot of surface trims. All right, so we get the point now that it's going around there. So let me just jump. So one thing to look forward on here is look for a thicken because eventually they're going to thicken the thing. So if we just keep jumping forward, Oh, they're going to go ahead and do all of these. So you can see that they're fitting the sweeps for those. You see that? Fitting those as solids. And then they're just going to apply fillets to the ends of them. You see that? Like that. Really cool way of doing it. So we will keep on moving forward. And we get the picture with these that we're fitting these guys as sweeps. So we'll just jump forward there. And we'll just look for all the sweeps here. Sweeps and fillets are all kind of along the same lines there. There we go. And let's go here. Let's jump there. Now, go ahead and turn on. Now they're going to go ahead and cut away all of this stuff here. Looks like. So we're going to trim these guys and create that pocket there. You could have done that before, but it's all however you want to go about doing it, right? People will sometimes take different approaches. So, and then we're going to trim all these guys together and cut them away. So they put all those together. Trim and cut. Look at that. That is really cool. Big old piece there. All of that. And then we're going to worry about the solids here in a second. So they do a delete phase here. Let's see where that is. Just want to see that. Remember, we can open it. Oh, they deleted faces on every one of the cylinders. These guys, in order to make them surfaces, just to trim them in. Right. So as a way to say, let's trim those bad boys in to the main piece, which is going to take that a second to calculate. And now just keep dressing up the pieces here. So turn that off. Just have a few more to do. Trimming those in and then filleting them in. It's a very impressive model here. And we'll do the rest of these. Just jump forward here. Now we are going to prep, as you can see, for the master cut all the way around the outside. And because this surface, it's so complicated, there's almost zero chance you could just thicken it, right? They went ahead and did an offset that worked. So they did an offset, and then they're going to trim all the way around the outside, probably, and do what we did last week, one of those solidifies. We'll see. We'll see if they use the solidify in order to create a solid from there. But now we're going to go ahead and trim. Okay, what they decided to do is kind of trim the top and the sides together and do it in stages, which this tends to happen with really complicated surface parts because you have to narrow it down to, like, you might have an area where it just doesn't trim properly, and in order to narrow it down and know where you're running into a problem, trim it in stages. So trim all the top to sides, and then do the sides to the other side, all in batches, right? That's kind of the gist of it. And then we're trimming that back side there. So yeah, they're not going to go after like what I was talking about, the full-on solidify approach, because this is so complicated that that would be really difficult to try to nail first try, and then you're stuck trying to figure out why it's not trimming together, and you're like troubleshooting in it, taking forever. All right. So the reason why I went ahead and rolled forward there is I saw that they did a copy paste another mesh there. So that told me that that was probably the last trim before it converted it to a solid. So when you trimmed it together into a solid, there we go. So very impressive. And then from there, roll forward, and they have other mesh pieces here. Just a second. The other components, right? And I'm just going to roll forward for those, just because we are limited on time here, but I'll run forward a little faster on that. So all right, so let's just turn that off. So we did some dress up stuff though first. So they definitely brought in the rest of the pieces, but before they get started on that next section here, looks like they still have a few more steps to go. And as I'm noticing right now, this is just the heat shield that they modeled, or the section. And the imported bodies are from a separate project. So this shows how they actually broke this up into separate parts. So I'll just zoom out here. And you see now they imported that they modeled that as a separate part. And imported this as a separate part. And then just did Boolean merge all together. So yeah, the heat shield is what I wanted to cover mainly today anyway. So this is just a really cool surface modeling part that I wanted to roll back and show. I might consider maybe doing the catalytic converter and the O2 sensor thing next week, or we might jump over to another subject altogether. We'll just see how the next one, the prep for the next one goes. But hopefully this was valuable for everybody, kind of seeing an advanced surface modeling project. And then one of the wrinkles in this one is the fact that we actually modeled it off of an exported CAD model into a polygon, which happens in a lot of automotive aerospace industries. So with that, we'll go ahead and jump back over to the PowerPoint. I hope everyone has been enjoying the RE Lab webinar, and I'm always striving to make it better and gather input from a variety of sources. And I had the idea to create a survey and put out a survey just asking for feedback. Mainly the feedback is just to gather data points on the topics, the applications, and if there are any other ideas of applications that people might like us to focus on, and just kind of get the pulse of what you guys like to see, what you like to hear. So this is a very open forum. it asks for some feedback and suggestions, and we'll go through those and implement those. Um, so if you have any proposed topics or things that you might want to learn about DesignX, then go ahead and scan this QR code. It takes you straight to a form, and we will take that and implement it.